I'm starting from this side because there is a BMS and it's harder to damage cells. If you start from this side, you can damage cells. Well, it depends on case of the battery, but yeah, it's easier just do it by brute force because no one would use BMS. Okay, so the same color, and that indicates us that it is the same manufacturer, Samsung cells. Very good. I'm pleased with that. A lot of gunk. Well, not gunk. That's sticky tape. That's much better than these cells. So these with gunk, which doesn't come off easily. So I will charge them up until they're full. So it's 4.2 volts, and then leave it for a few weeks in my drawer, and then I will use this to check the capacity. And if it's more than 1 amp, well, you can keep it. If it's less than amp, you can throw them away straight away with the rubbish. Yeah, but 1 amp, it's not really useful for these cells because most of these cells are more than 1 amp, and you don't want to include a bad cell in your pack because that can ruin everything. For my electric motorcycle, I'm planning of putting every cell that is above 1.8 amps. I will want to go 2 amps and above, but I don't have that much cell, so I lower my threshold to 1.8 and above. Oops, that was a spark. Red cells, they could be Sanyo. So that's one respectable manufacturer which manufactures good cells, along with Samsung, LG, a few others. Can't see written Sanyo anywhere. I hope it's Sanyo. Let's check the voltage. Yeah, 3.7, very good. Very good. I still can't see Sanyo written, but a lot of other letters and numbers. I will probably Google it. What's that? Okay. So far so good. Let's check this one. Yeah. 3.73. Very good. And this one. Yeah, the same, 3.7. Very good. Means it's decent. Means the cell is good, but how good we can see only when we measure the capacity. And after 2 weeks, if it still holds the charge. So if after we gonna charge it till 4.2, and if it still holds the charge, for example, if it's still 4.1, so it's good enough, and we can measure capacitance. After capacity measure, we can decide if it's more than 1.8 amp hours, then it's going to pack. If it's less, it goes in my drawer, waiting for another project probably. And if it's lower than 1 amp, it's going to a recycle bin. Okay, different color, orange. Doesn't look very good. Okay, it's, yeah, the fluid is out. So I guess these two cells completely ruined. You can see how different. Okay, let me crack that open and I will show you. As you can see, focus, yeah, so this is different color, and under that you can see a little bit different, and yeah, underneath that something's happened, and these one looks different. So I hope these are bad, these probably good. Let's check that. That's rubbish. don't ever cut two wires at once. So, because when you cut those, you can shorten them out. It's not one cell in a pack to ruin everything. Of course, I will put fuses in, so if one battery shortens out, the fuse is blown, and you can tell which cell caused that. But for example, if that cell draws current slowly, so your battery pack will deplete and can damage other cells in the same group. And if you're not familiar with lithium-ion batteries, I would suggest to look at more videos, because they are pretty dangerous, and if you mistreat them, they can explode, catch fire. Well, I guess you still can remember the Samsung phone, Samsung Note feature catching fire. And these cells has a lot of energy, a lot of power. So we could calculate the nominal voltage is 3.6 volts, and let's say you discharge them. Well, I'm not sure what current you can get out of them if you short them out, but it's a lot. You can discharge them. Some of the cells you can discharge at pretty good rates. So 5C, for example, 6C. So 6C means 6 times the capacity. So if this is 1.8 amp, so 6 times that, you can discharge one cell. So that's a lot of power. Okay, 1.8 milliamp hours, no name battery. I'm not sure. Doesn't show anything. Yeah, looks like rubbish cells.